ሰላም ተማሪዎች እንደምን አላችሁ? ዛሬ about system of linear equation with no solution, unique solution and infinitely many solution የሚለውን ይዤላችሁ መጥቻለሁ። Let us see this together. ከላይ ያለው system of linear equation we can express in the form of what? Matrix form express ማድረግ እንችላለን. So this is 8a, this is 12, here is 6 ይሆናል times is x y is equals to 2b ይሆናል። ስለዚህ ይሄኛው ኮኤፊሺየንት ማትሪክስ ነው ማለት ነው። ክሬመርስ ሩል አፕላይ ማድረግ እንችላለን። ምን ብለናል? in case of ክሬመርስ ሩል this is the coefficient matrix, that means let it be d determinant of coefficient matrix is equals 8a 12 with 6. We can express such forms. But that this is equals to 48 minus 12a. What is the coefficient for? To solve this x, we substitute this coefficient of x by constant b. We can say this is what? Since it is expressed at the forms ax is equal to b forms. So, in case dx is equal to determinant with respect to x, this is 2b a and 6, which is equal to 12 minus a times b. What about dy? With respect to dy, that means to solve y, we substitute all coefficient of y by the constant. Here is b, capital B, which is equals 8, 12, 2 and b here, which is equals 8b minus 24. In call, you have to have cases to have a unique solution, no solution and infinitely many solutions. In that case, you know, to have a unique solution, the first one, that means to have one or unique solution, the determinant, that is the coefficient matrix D, must be different from 0, which shows that 48 minus 12a different from what? 0. What does it imply? This shows that 48 is different from 12a. So negative 12a order to the right side of this inequality scenario, meanwhile 12a order. To find a, divide both sides 12. This shows that 4 is different from a. What about the value of b? B can be here any real number. When come to the second one, ሁለተኛውን case, that means no solutions, but shows that in case of no solution, the coefficient of determinant, that means coefficient matrix, is equals to 0, and the other values with respect to dx or dy different from 1, 0 in that case. This implies that, what does it imply? This shows that determinant d, 48 minus 12a is equals to 0. What the value of a? As we did before, a is equals to 4. A is equals 4, but what about dx and dy? And at the same time, coefficient matrix, this is dx is different from 0. The same for the case of this dy is different from 0. It must be. If a is equal 4 means, what about dx? That means 12 minus 4b is different from 0. For the value of b, this implies 12 is different from 4b. In then solve b. b is different from 3. It is the same for the case of this also. 8b minus 24 is different from 0. Again b different from, that is 3. So in this case, the system, what? This system has no solution. ስለዚህ ምን ይሆናል? ኮኤፊሺየንት ማትሪክሳችን 0 ይሆንና the other value for the case of dx dy dz ሊሆን ይችላል 3 by 3 system of linear equation ስለሚሆን order 3. In that case, that dx dy dz different from 0 ከሆነ we can say that the system has no solution እንላለን። Let's come to for the third case. But the third case, it has infinitely many solution. Infinitely many solution. When the system has infinitely many solution using this determinant rule, that means coefficient matrix D is equal 0. At the same time, the value, that means with respect to dx is equal 0. The same with respect to dy, that is equals to 0. ስለዚህ dx dy እና d all are 0 መሆን አለባቸው። What does it imply? It shows that d is equal 0 when a is equals 4 ብለናል. We did here. እዚህ ጋር ሰርተናል. At the same time, dx is equal 0 when and b is equals to 3. At this time, the system of linear equations that we have, it is expressed the form of 8, 12, a and 6 times xy is equals to b has infinitely many solutions for the case of this one. ስለዚህ በዚህ ማትሪክስ ፎርም ዲተርሚን ማድረግ እንችላለን whether it has unique solution, no solution እና infinite many solution ማለት እንችላለን ወይም a system of linear equation has no solution, unique solution, infinitely many solution ለማለት what you have, it must satisfy what? In case a1 over a2 as we said before is equals b1 over b2, we call this is it has no solution for the quotient matrix. But this is different from c1 over c2 as we said before. In this case, the system has no solution. Or instead, we can say that the quotient matrix that we determined a1 times b2 minus, we can say it is b1 times a2 is equals to 0 and at the same time it is a1 c2 is different from a2 c1. At the same time b1 c2 is different from b2 c1. It must satisfy this. If that's so, we can say that the system of linear equation has no solution. That case is satisfied. In both cases, you get the same result. Either you have to equate this form, or either you have to determine using what? Determinant forms. When it comes to the second one, it has a unique solution. Reverse. That means a1 over a2 different from b1 over b2. But what was the case of c1 and c2? c1 and c2, whatever the case, more natural. Or using matrix rule, what we have that a1 using determinant b2 is different from b1 times a2 when this determinant is different from 0 but the case of c1 and c2, whatever the case. Let's come to for the last one, the case of it has infinitely many solution. We have to express a1 over a2 is equals to b1 over b2, which is equals to c1 over c2. Here it must satisfy this one for the case of equality, or we may apply determinants. In case of determinant, it says that a1 times b2 minus a2 times b1 is equals to 0, or that means a1 times b2 is equals to what? This is a2 times b1 ይሆናል ማለት ነው። በዚህ አይነት መንገድ ሳሰብ similarly for the case of the other one, this is a1 times c2 minus a2 times c1 is equal to 0, or this implies that a1 times c2 is equals to a2 times c1 ይሆናል ማለት ነው። Or it may be the other one, the other option, that means b1 times c2 minus b2 times c1 is equal to 0. It shows that, or this is b1 times c2 is equals to b2 times c1 here. ስለዚህ እነዚህን የሚያሟላ ከሆነ we can say the system of linear equation has infinitely many solutions እንላለን ማለት ነው። ስለዚህ ሌሎችንም ጥያቄዎች በተመሳሳይ መስራት ትችላላችሁ። ማንኛውም ጥያቄ ካላችሁ ኮሜንት ላይ አስቀምጡልን። ቻናሉን ሰብስክራይብ፣ ላይክ እና ሼር ማድረጋችሁን አትርሱ። ለዛሬ እዚህ ላይ ይበቃናል። ባይ ባይ።